All right, so I'll just repeat what I said. So let's say the magic number is between 1 and 10.
Okay.
So your guy here maybe starts at 1, then he tries 2, then he tries 3, and that's going to be based on beats on the drum, if you will. This guy maybe starts at 10, then 9, then 8, then 7, so on and so forth. This guy's going to start at maybe 5, then 4, then 3, then 2, then 1, then 6, then 7, then 8, then 9, something like that.
Yeah.
And then maybe this guy counts 1, 3, 5, 7, 9, and then he counts 2, 4, 6, 8, 10, maybe evens and odds,
Yeah.
something like that. Just so he kind of simulates these guys being from different mining pools, each kind of approaching things at different speeds. So they each kind of have an equal chance, let's say, of stumbling upon the answer at the same time. All right. And then, maybe you say each of these guys, let's say they're the same speed. So every 1 second, this guy does something. Every 1 second, this guy does something. So this guy is going to try 10. And then a second later, he's going to try 9. Then a second later, he's going to try 8, so on and so forth. Now, the reality is that this guy, the potential block, the answer to that thing is just a random number, which is way simpler math than real blockchains work, right?
Yeah.
So he's going to be a random number. So let's assume that 6 seconds in, player 2 happens to be the one who finds the number first. Okay, he finds it faster than you did. So he's going to turn green, let's say. And then what's going to happen is everything else stops. So when he turns green, all these other guys then are notified that the block has potentially been solved. All right, so what he's going to do is he's going to send his number to player 1. Let's say the number was 7.
Okay.
He's going to send the number to you, to all the other guys. All those other guys are going to check to see if their block opens to the number 7. If that's the random number that they had selected.
Yeah, by put it on a number or something.
Yeah, so this guy's just going to be an object.
Okay.
And this guy is going to have that random number associated with it. Now, we don't know the problem might be is if this guy has a random number of 7 and this guy has a random number of 9. Okay, then they wouldn't match. But the hope is that all of these guys are working on the same block. So as soon as one of them figures out the random number for this block, if they share that random number with the other people, they'll each be able to unlock their block with that same number. They'll say, is the number 7? And their block will say, yes, it is. So once they all can corroborate that it's a 7, make sense?
Yeah.
Then that potential block becomes the first block on the real blockchain.
Okay.
All right. So then a bunch of transactions occur. So now we have a new potential block. So these guys are they're off to the races again. So, new work is found. They're working on a new block now. This guy's going to become the second block. All right. So now they're looking for this block is going to have a random number. This guy's beating on the drum or whatever. These guys are doing their little weird algorithm for it once per second just to make it so it's some kind of competition. And then ultimately somebody gets the right answer. So let's say you get it this time and you found that the answer is 9.
Okay.
So you're going to pass 9 around to all these other guys. They'll each try the 9. It says, yeah, 9 worked for me. Yeah, 9 worked for me. Yeah, 9 worked for me. So if they all can say 9 worked, then what happens is this potential block becomes
the second block.
Block 2 on the actual blockchain. Okay. So this is a very generic blockchain, right?
Yeah.
Does it kind of make sense how this is working?
Yes, that makes sense. But here's the question: like, if you say the chain race and random number, it's fine for me. I can do that on VR. But the thing that, like, example, player got random number on number 7, and the player number 2 is going to get a random number on number 9. So.
But he wouldn't. So the block that gets shared with all these guys, the hope is that all these guys are working on an identical block. That's how blockchain works. Okay, because what happens is if somebody underhanded goes to your pool and hands you a slightly modified block, what would happen is that when you find an answer, your answer won't work for our blocks. And if we find an answer, our answer won't work for your block. So you would say, that doesn't work. Wrong answer. So we got to go, then your block gets thrown out if it works in the other ones, that kind of stuff.
Yeah.
Then we have to decide, well, how do we corroborate this? Then we go back and have to keep working. Okay. But in the tutorial mode of this guy, it's you versus 3 computer guys, right? And we can assume that all these blocks are legitimate blocks, but the block doesn't get added to the blockchain until one of the 4 people has found a solution for that block, shared that solution with the other 3 people, and they all say, yes, that solution works on my block as well. Does that make sense?
Yeah. So basically, just like do it right now on the V0 first. So the blockchain is later, implementation by different people.
Yeah. So this isn't doing any sort of crazy math. This is just guessing a random number. So then, this would be the high level version of this. Then what you would probably do, so this would be step 1. Step 2 would probably be saying, instead of guessing a random number, what actually is happening is, you would teach them about a hashing algorithm. So what you'd actually do is you say, instead of guessing a random number, you would guess a bigger random number, some 256-bit value. And you would run that value through a hashing algorithm. How does the hashing algorithm work? It takes an arbitrary size input and spits out a fixed size output. So no matter what you dump into this algorithm, it's going to spit out 256-bit stuff. And you're looking for something that starts with a certain number of zeros. 5 zeros, let's say, something like that. So you're taking the initial starting point and saying, okay, you're just guessing random numbers because humans can understand that. And whoever gets this number first wins, right? And then as long as the other guys can all say, oh yeah, that my block says that random number is good too. Then the next step is how does it actually work differently than just random numbers? So instead of a random number, it's actually this value which goes through one of, you can mention like the 4 popular hashing algorithms, so SHA-256, Equihash, stuff like that. It goes through one of these 4 algorithms, spits out a result, and you're looking for a result that has a certain number of zeros at the beginning of it. Well, how do we know how many zeros? Well, it depends on which of these algorithms you're using and how often a new block is supposed to be found. Okay? If a block is supposed to be found every 5 minutes, and in order to, let's say there's enough people mining at the same time that a new block is found in 3 minutes, then the next round, the next block, we need to up the difficulty. Instead of 4 zeros in a row, maybe it's 5 zeros in a row at the beginning of it, right?
Yeah.
So hopefully it takes a little bit longer for the next block because you're looking for an even more unique number to guess. Make sense?
Yes.
Okay, so this is step 1. Step 2 is to take them from this and say, instead of just a random number, here's what hashing algorithms are about. Make sense? Here's the 4 popular hashing algorithms, whatever it is, and you'll have to come up with a little puzzly game like this that takes them one step past, the banging the drums to guess a number. Now it's like, okay, well, here's how Equihash works, and not at the super, super detailed math. You're not going to have them do the crazy math, but you want them to be able to go from this to understand that there's different ways of guessing those random numbers. So they need to understand the different algorithms at the high level, and then also understand what difficulty means.
Okay.
Just that whole idea of generating a block so often and that kind of stuff. That makes some sense?
Makes sense.
All right. So then once they have that, then they've had the training of guessing the number. So now what ends up happening is the final implementation. So, this is kind of the tutorial. So here's the physical tutorial. Then what's actually happening here when you're guessing your number in real life for real blockchain, then you don't have to tell them how your algorithm works. All you have to do is then you dump them into, a real world where maybe there's like 3 or 4 different stations. And depending on which station they go to, they're actually testing more numbers more often. Maybe this guy is just, beating a couple of drums like this. But maybe another guy allows you to, if it's a more, advanced movement, it counts more. Like you test more numbers per second. Okay, so maybe with the 2 drums, maybe you can only do 1 number in a second, 1 number per second. So that's 1, 2, 3, and even if you hit them too fast, it's still only 1 per second. Okay, well maybe you have another one that gives you 4 drums. So now you can do 2 numbers per second because you can beat the drums more quickly or something. It'll allow you to hit them more quickly. Yeah. So you have like 3 or 4 stations that, simple exercise, more vigorous exercise, guessing numbers more often, guessing numbers less often. That doesn't mean you'll lose, but it means that you're less chance.
Yeah.
And then the reality is this then becomes a network application because in the real life version of this, you're player 1, but player 2 might actually be a real person. Player 4 might be a real person, not a computer person.
Okay.
Kind of make sense?
Yeah.
We're going with this?
Yep. So
Go.
first I'm gonna create like a first person gonna play the game. After the game ends, it's gonna be like the next person continue, or you connect from you want this connect from Vi to Oculus, so connect from device to device.
Well, right, into some sort of cloud thing. So you can see how many other people are in competition with you. You don't actually need to see them there. Maybe you have a little heads up thing. You have your 3 or 4 stations in front of you. So if we kind of just draw this out. So so we have steps. Basic intro to blockchain.
Okay.
With number guessing. See slide 1. And then step 2 is more advanced intro to existing algorithms, where our simple number guesses from slide 1 are further explained as hashes that are tested against a hashing algorithm whose results are a hash with some number of leading zeros. The more zeros, next thing would be, how does difficulty work? The more zeros, the more difficult, which means the more guesses it will take on average to solve a block, which means a block will be solved less often unless more people are mining to increase the number of guesses. All right, so basic intro, more advanced intro, how does difficulty work, and then finally the network-based game where individuals log into a shared mining world and can visit one of 3, can visit, one of several stations where each station allows them to guess more or less often depending on the difficulty of the movements at the station. The more exercise they are getting, the faster they are mining. That kind of makes sense?
Yeah.
So ultimately, people who exercise either a lot or more vigorously will, on average, earn more coins.
Okay.
Kind of make sense?
Yeah.
All right. So what I'll do here is I'll email you a link to this.
Yeah.
because you can now modify this as well, and then I'll upload the video and send you a link to the video.
Okay.
So you can review this for your requirements document.
Yeah.
Sound good?
Sounds good.
All right.
All right.